Hi everyone, welcome back to a new video. Today we'll talk about hydrolysis of primary amide, secondary amide, and acetal. So basically, hydrolysis is the inverse of the synthesis of primary amide, secondary amide, and alcohol. So in this case, here we start with an amine for a primary amide. For a secondary amide, we start with an amine, and then for the end product of an alcohol synthesis, we start with an acetal. So let's start with the hydrolysis of a primary amide. So first of all, what's going to happen is the pi bond, or the pi electrons of the double bond between the carbon and the nitrogen is going to get protonated and create a resonance here where the carbon is going to get a formal positive charge, or the nitrogen get a formal positive charge. And this formal positive charge is going to be attacked by water right here, forming a tetrahedral carbon here. Now, because of the oxygen here being positively charged, we want to deprotonate it with water again to give us this OH group here. And now we do want to get rid of this part here, so we end up with our final product, which is the ketone. And in here, there's going to be an intramolecular reaction where this nitrogen here, or the lone pair and the nitrogens, are going to grab this hydrogen attached to this oxygen, and then the bond here is going to roll onto the oxygen, forming a negative charge. So here we have the now protonated nitrogen that is positively charged, ready to leave as a leaving group. And we have this oxygen here that's negatively charged. So this rolls back to the nitrogen and leaves. And then this one rolls here to form a double bond. And then this gives us our final product here, which is a ketone and our primary amide. All right. Now, the hydrolysis for a secondary amide is going to be a little different. We know that the double bond is located different. It's differently located than within primary amide because of it being an amine. So this double bond is going to attack and again be protonated. This will then form a resonance here where there's a positive charge on this carbon, or positive charge on this nitrogen. Now water is going to attack the carbon, forming the same type of step as above. And once this one here is positively charged, then we deprotonate it again to get rid of that positive charge. This bond rolls back on the oxygen, giving the whole molecule a neutral charge, and then the intramolecular reaction occurs again, giving us with the same product as above, and then we end up with our ketone and our secondary amide. So for the amides, The only thing that really differs is where the actual hydrogen or the protonation goes to. So for a primary amide, this bond here that attacks the protonation, the hydrogen can whether go on the carbon or on the nitrogen. In this case, we want the hydrogen to go on to the nitrogen here, so we can have a positively charged carbon into resonance. In this case here, the protonation, the hydrogen, sorry, the proton is going to attach to this end of the double bond, so we can also have a positively charged carbon through resonance. So this is really the only step that differs between amide and amine. Now, for acetal, or for the hydrolysis of an acetal, we start by protonating one of the CH3O groups here, or the esters. So we protonate it, give it a positive charge. Now it's ready to leave, so CH3OH leaves, and this forms a positive charge, or a resonance structure, but a positive charge on this carbon here, which allows water to attack it, forming this new intermediate that is positively charged. So we do as usual, we deprotonate it. This bond here rolls back on the oxygen, giving the oxygen a neutral charge. And now we are back with our hemiacetal, and the only thing left is to redo that again, but with the other CH3O group here. So we protonate it again, making it a positive charge, ready to leave. Now that it's protonated and positively charged, it rolls back, it leaves. Now there's still a resonance structure here, and the only thing left for us to do to get back to our initial product, our ketone, is to deprotonate here. Actually, I got this wrong here. It's better to deprotonate this resonance intermediate, and then the bond between the O and the H is going to go and then form the double bond here. So you roll, deprotonate, the bond here between the oxygen and hydrogen rolls down, forming our ketone and H3O plus. So those are the steps for the hydrolysis of acetal. So I hope this helped, and if you have any question, please leave them in the comments. Thank you.